We live in a fire-adapted and sometimes fire-dominated landscape. For us, wildfires aren't distant headlines. They are recurring events that shape our environment, threaten our communities, and challenge our forest management. This video isn't about fear. It's about understanding. We're going to apply the science of forestry to these local events, analyzing why these fires burned the way they did, and what we can learn from them to manage the next burn. Every wildfire starts with the fire triangle. You must have heat for ignition, oxygen for combustion, and fuel to burn. Remove any one and the fire dies. Heat sources around here are often human-caused, though summer lightning is a constant threat. But let's focus on fuel, the materials that define our local fire risk. Our region has a vast range of fuels. You have fast-burning fine fuels, the dry grasses and light brush you see on the valley floor. And you have heavy fuels, the dense chaparral and timber found at higher elevations. Take the Fry Mesa fire in 2017. That incident primarily exhibited surface fire behavior. The light, fine fuels dried quickly, creating rapid-moving flames across the landscape. The speed of the spread was the main concern, as it threatened structures quickly. Fuel moisture content is key. When our relative humidity drops below 15%, even heavy fuels become receptive to ignition. This transition is what turns a manageable fire into a runaway blaze. Finally, oxygen, often delivered by wind. Wind is the primary reason the spread rate accelerates, pushing the heat forward and increasing the chemical reaction. To predict how a fire moves, we look at the fire behavior triangle: fuel, weather, and topography. The Nuttall Fire of 2004 on Mount Graham, Arizona is a classic case study in how these three elements combine to create a catastrophic event. It demonstrated the overwhelming power of topography and weather. Fire spreads exponentially faster up a slope. Why? Because the heat, driven by convection, rises and is forced closer to the unburned fuels above the fire, preheating them instantly. A steep canyon can act like a chimney, accelerating the fire into a violent column. When a fire encounters a high wind corridor, that rate of spread becomes uncontrollable. Strong, localized winds can cause massive spotting, carrying embers far ahead of the main fire line, igniting new fires and rapidly overwhelming containment efforts. When the fire moves from the surface up into the canopy via ladder fuels, small trees and low branches, it becomes a crown fire. The Nuttall Fire, burning through dense timber, exhibited this extreme behavior, consuming vast tracts of forest and leaving behind devastating consequences. The sheer scale of the Nuttall Fire underscored the need for fuel management. Reducing that dense fuel load breaks the chain, ensuring the fire remains a manageable surface event, rather than a crown fire. Now, let's look at the two 2017 incidents: Fry Mesa and the Pinal Fire. While Fry Mesa was a fast, aggressive surface fire, the Pinal Fire was a protracted battle in the higher, rugged terrain. The Pinal Fire burned through heavier, mixed conifer forests. This high-intensity burn has a different impact. It becomes stand-replacing, meaning it kills the majority of the mature trees, fundamentally resetting the ecosystem. But fire isn't purely a destructive force. Section 10.3 of our study focuses on fire's ecological role. In healthy ecosystems, low-intensity fire is essential. Low-intensity fires, like a controlled surface fire, quickly perform two vital functions: nutrient cycling and fuel reduction. The fire converts slowly decaying organic matter into ash, immediately releasing essential minerals like potassium and calcium back into the soil. By regularly clearing out fine fuels and underbrush, we prevent the buildup that would otherwise feed a catastrophic crown fire. This is how we ensure that the next inevitable fire serves as a cleanser, rather than a killer. The footage we've seen this year reminds us that the threat isn't diminishing. Drier conditions, longer fire seasons, and accumulated fuels mean managing fire risk is a continuous commitment. It is the new normal. The data shows our fire seasons are getting longer and the severity is increasing. This is why our focus has shifted dramatically toward mitigation and proactive management. We are all part of the fire equation. Understanding the role of fuel, weather, and topography empowers us to make smarter decisions about how we build, how we manage our land, and how we respond when the inevitable happens. From the fast, low-elevation spread of Fry Mesa to the high-intensity impact of the Pinal and Nuttall fires, the lessons are clear. Fire is a force that demands respect, but also understanding. By knowing the science behind the flame, we can manage our forests not just to survive fire, but to thrive in its natural, necessary cycle. Thank you for watching.